All right, so buckle up, because today we're taking a deep dive into something truly wild: the persistence of flat Earth beliefs in the 21st century.
It's one of those things that might seem like almost funny at first glance,
Right.
but when you really start digging into it,
Yeah,
there's this whole layer of like how people interpret the world around them,
absolutely. And that's exactly what we're doing today.
Yeah.
We're diving headfirst into excerpts from the Wikipedia article on modern flat Earth beliefs.
Okay.
And I gotta say, even just skimming through it, I was blown away by how much there is to unpack about this seemingly outlandish idea.
It really shows you how even something like this
Yeah.
can connect to bigger trends, like how ideas evolve over time and how people form beliefs.
Exactly. And speaking of evolving ideas, let's rewind the clock a bit. Our trusty Wikipedia guide takes us all the way back to the 1800s with a man named Samuel Rowbotham and his rather confidently titled book, Earth Not a Globe.
Catchy.
Talk about a bold statement, but it's his Bedford-level experiment that really piqued my interest.
Oh, tell me more about that.
He basically claimed that by using canals and telescopes, he had proof that the Earth wasn't curved.
So how does that hold up? We have like pictures from space.
Right. Well, that's where things get interesting,
Okay.
because it's not necessarily about a lack of scientific understanding, but rather, like you were saying earlier, how our perspective shapes our interpretation.
I see where you're going with this.
The Earth is so massive that its curvature is really subtle over short distances, right?
Exactly. It's
But
all about scale.
exactly. So Rowbotham's experiment, while seemingly convincing to some, really highlights how our limited perspective can lead to misinterpretations.
And this actually ties into another crucial aspect of this whole movement, even way back then: belief systems.
Oh, absolutely.
This wasn't just Rowbotham saying, hey, I have a different scientific theory. He was deeply religious, and he saw traditional astronomy as directly contradicting his interpretation of Scripture.
That's a really important point, actually,
Right.
because it suggests that these beliefs aren't just about someone missing a science class or two.
Right.
It often stems from a much deeper place,
Absolutely.
a rejection of established authority, especially when it clashes with pre-existing worldviews.
Yeah, and you see that tension, that push and pull between what's considered established knowledge and alternative explanation. It continues to fuel the Flat Earth movement even today.
It's fascinating, really. And speaking of which, as we move into the late 19th and early 20th centuries, things get even more interesting.
Oh, how so?
Well, the Wikipedia article introduces a whole cast of characters who pick up this flat Earth mantle, and each of them brings their own unique flavor to the movement.
So it becomes less about a unified movement and more about the individuals drawn to this idea.
Exactly. And for totally different reasons, too, which I think is really interesting. Like,
Yeah.
we've got figures like Lady Elizabeth Blount, who is so committed to this idea that she was distributing pamphlets about it, even targeting children.
Wow, she was really dedicated.
Right. Talk about dedication.
That's something else.
And then you have someone like John Jasper, a formerly enslaved man who incorporated flat Earth ideas into his sermons, which I think speaks to how this idea could resonate with people from all walks of life.
It's like this one idea, but it's being interpreted and utilized in such different ways by different people.
Right. And then there's John Hampton,
Okay.
who took it upon himself to publicly debate scientists.
Oh, wow.
Like, he was challenging the very foundation of accepted knowledge.
It's interesting, though, right? Because despite all their differences,
Yeah.
these figures all shared a common thread:
What's that?
this distrust of conventional wisdom and a real yearning for alternative explanations that often aligned with their own personal beliefs and experiences.
And we can't forget about the irony of Joshua Slocum.
Who's that?
He was the first person to sail solo around the world. Right. You'd think that would be the ultimate proof.
Right.
But he actually ran into a group of flat earthers in South Africa who were skeptical of his journey.
Oh, no way.
It just goes to show you how deeply ingrained these beliefs can be, even in the face of what seems like undeniable evidence.
Yeah, it really makes you wonder what drives that level of conviction.
It does, but that's a question for later in our deep dive,
Okay.
because things are about to take a turn for the organized with the emergence of the International Flat Earth Research Society.
Wait, there's a whole society for this?
Oh yeah, a formal organization
Wow.
with official publications and everything.
That's incredible.
It's hard to imagine, right? But it just goes to show you, this idea has some legs.
It really does, and it takes us right through some of the most significant scientific advancements of the 20th century, too.
Oh, absolutely. It's setting up a fascinating contrast between, like, scientific progress on one hand
Right.
and the persistence of these alternative beliefs on the other.
I can't wait to hear more about that.
So we've got this whole society dedicated to a flat Earth happening at the same time that humanity is sending satellites into orbit.
It's kind of mind-boggling when you think about it, right?
It really is, and it makes me wonder, how did they reconcile those scientific advancements, like, with their worldview?
Well, that's where Samuel Shenton comes in.
Okay.
He takes the reins of the Flat Earth Society in the mid-20th century, a time of like incredible breakthroughs in the space exploration.
Right, when we're seeing the first images of Earth from space.
Exactly, but Shenton, he sticks to his beliefs.
Even with this visual evidence.
He actually compared Sputnik's orbit to a ship just sailing around an island.
So instead of seeing that as evidence that contradicted their beliefs, they kind of reframed it to fit within their existing model of the world.
Exactly, and Shenton wasn't alone in this.
Right.
A lot of flat earthers saw those early space photos not as proof of a round Earth,
Right.
but as evidence of a conspiracy.
Like they were faked or manipulated in some way.
Exactly. It all just fueled their distrust in established institutions even more.
It's interesting how that distrust is such a recurring theme, isn't it?
Oh, absolutely. And it only intensifies under the leadership of Charles K. Johnson.
What did he do?
He takes over the society in the 1970s, moves their headquarters to California, and shifts the focus even more towards these government conspiracies, particularly those involving NASA.
The classic "they're hiding something from us" narrative.
Precisely. Johnson was all about it.
Like what?
He popularized this idea that NASA was perpetrating a massive hoax, even claiming the Earth was actually a disk enclosed by a giant ice wall, Antarctica.
Wait, so like we just hit the edge and there's a wall of ice.
That was the idea, yeah.
Okay, I gotta say, that image is both terrifying and weirdly intriguing.
It's definitely a vivid one.
But I guess it makes sense in a way, right? If you believe the Earth is flat, you have to address the whole falling off the edge issue.
Exactly. And the ice wall was their way of explaining that.
Like a giant barrier holding everything in.
Precisely.
So we have this society promoting these increasingly elaborate theories.
Yeah.
And then, in a strange twist of fate,
What happened?
a fire destroys all of their records.
Oh, wow. Are you serious?
Seriously. Talk about a plot twist.
What did they do?
It was a huge setback, but it wasn't the end. Because, like a phoenix rising from the ashes, the internet breathed new life into the Flat Earth movement.
Ah, the internet, of course.
It was the perfect platform.
In what way?
Well, it allowed them to connect with like-minded individuals all over the world and spread their ideas far and wide.
It's fascinating how the internet has completely transformed the way we consume and share information, hasn't it?
Totally. And in this case, it allowed the Flat Earth movement to not only survive, but thrive.
And that brings us to the modern era of flat Earth belief.
Where online communities and social media play a huge role.
A double-edged sword, really.
How so?
Well, on one hand, the internet gives us access to a wealth of information like never before, right? But on the other hand, it's also created these echo chambers where misinformation can spread like wildfire.
It's like the ultimate breeding ground for confirmation bias.
Exactly. The algorithms feed you what you already believe, which just reinforces those beliefs, whether they're accurate or not.
And I think this next bit really highlights that issue.
Okay, what is it?
The Wikipedia article cites a YouGov poll that found that only 66% of millennials are absolutely certain the Earth is round.
Wait, seriously?
Seriously, it suggests that this skepticism towards established science is becoming more common, especially among younger generations.
That's a bit concerning.
It is, because it's not just about a lack of access to information anymore. It's more about how people are evaluating and processing that information.
And who they trust, what they see as credible.
Exactly. And that skepticism, coupled with these online echo chambers and a general distrust of authority figures and institutions,
It creates a perfect storm.
it really does. And it's not just fertile ground for flat Earth beliefs, but for all sorts of conspiracy theories.
It's like questioning the very shape of the Earth opens the door to questioning everything else.
Exactly. And it raises a really interesting question, I think.
What's that?
If people are willing to question something as fundamental as that, what does it say about our relationship with knowledge and truth in the digital age?
That's a big question.
It is, and it's one we could probably spend a whole other deep dive exploring.
I'd listen to that.
But for now, let's bring it back to the flat earthers themselves and their attempts to, scientifically prove their theories. It's kind of a paradox when you think about it.
Yeah, how so?
Well, you have this group of people who are, like, rejecting centuries of scientific knowledge.
Right.
But then they turn around and engage in their own forms of scientific inquiry.
It's like they want to disprove the system by using the system.
Exactly. It's fascinating, and it really speaks to how our minds work.
What do you mean?
Well, we don't just passively accept information, right?
Right.
We're constantly seeking out evidence that supports our existing beliefs, even if those beliefs challenge, like, the most fundamental truth.
And that makes sense.
Yeah,
Our beliefs, they shape how we see the world.
absolutely. And the Wikipedia article actually goes into some of these attempts to scientifically validate a flat Earth with varying degrees of, shall we say, success.
Oh, I've got to hear about this.
Well, for instance, there was this one group that tried to use a laser gyroscope to prove their point.
A laser gyroscope.
Yeah, it's a device that measures rotation.
Okay, and they thought that would disprove the Earth spinning.
That was the idea. But the thing is, a gyroscope, if it's working properly, it's going to detect rotation, right?
Right, so what happened?
Well, they did detect a rotation,
Oh, okay.
but instead of accepting that as evidence of the Earth's rotation,
Yeah.
they attributed it to the movement of the firmament.
Wait, the firmament? What's that?
Right, not everyone's up on their flat Earth terminology.
It sounds like something out of a fantasy novel.
Kind of, right.
Yeah.
Basically, in their model, the firmament is this dome or canopy that covers the whole Earth.
Like a snow globe.
Yeah, kind of like a giant snow globe.
So they're saying the gyroscope was picking up the movement of this dome, not the Earth itself.
Exactly. They essentially reinterpreted the evidence to fit within their existing framework.
It's amazing how the mind can do that.
It is. And it just goes to show you can't always just throw facts at people and expect them to change their minds.
Especially when those beliefs are tied to something bigger, like a whole worldview.
Absolutely. And the Wikipedia article mentions another experiment that highlights this.
What kind of experiment?
This one involved lasers and a really long stretch of water.
Okay.
And their goal was to prove that the water surface was perfectly flat.
To support the flat Earth idea.
Exactly. Their logic was if the Earth is curved, then the water should curve too, right?
Right, but the thing is, the Earth's curvature is so gradual, it's not like you'd see it over a small distance.
Exactly. And that's kind of where their experiment went wrong, or right, depending on how you look at it.
So what happened?
Well, their measurements actually did show a slight dip in the water's surface, which, aligns with what we know about the Earth's curvature.
Oh, so they accidentally proved themselves wrong.
In a way. But, of course, they had an explanation for that, too.
What did they say?
They attributed it to other factors, like wind or something.
So they dismissed the evidence that didn't support their view.
Pretty much, which, again, speaks to the power of confirmation bias.
It's like if something doesn't fit the narrative, you just ignore it or explain it away.
Exactly. It's a fascinating thing, and it makes you wonder, what does it all mean?
Like, what can
Yeah.
we learn from all of this?
Well, I think it reminds us that this goes beyond just a debate about the shape of the Earth,
It's about something bigger.
Yeah, it's about how we approach information, especially in this day and age where we're bombarded with so many different narratives.
And how do we decide what's true?
Exactly. It's about critical thinking. It's about evaluating your sources.
Being open-minded, but also discerning.
Absolutely.
Hmm.
And while it might be easy to just dismiss flat Earth beliefs as, like, ridiculous or whatever.
Yeah, it's easy to laugh it off.
It is. But I think they offer a really interesting window into how we form beliefs and how those beliefs shape our understanding of the world.
So what's the takeaway here? Should we all be questioning everything?
I don't know if it's about questioning everything, but I do think it's important to stay curious, to be open to new ideas, but also to approach those ideas with a critical eye.
And to remember that everyone has their own perspective, their own way of seeing the world.
Exactly. And sometimes exploring those different perspectives, even the ones that seem the most out there, can teach us a lot about ourselves and the world around us.
Well, you've definitely given me a lot to think about.
That's what we like to hear. And on that note, we've reached the end of our deep dive into the world of flat Earth beliefs.
Time flies when you're having fun, right?
It really does. So until next time, keep those minds curious and keep exploring, and we'll see you on our next deep dive.